Chemical kinetics is the branch of the physical chemistry. So it deals with the uh, rate of reaction, okay, and factors affecting the rate of reaction. Factors affecting the rate of reaction. Next, third one, and process of the reaction. Nothing but reaction mechanism. Okay. Here, chemical kinetics is a branch of physical chemistry. So it deals with nothing but it explains the rate of reaction, factors affecting the rate of reaction, and process, nothing but mechanism of the reaction. Okay, so one by one we discuss. First of all, rate of reaction. Okay, one by discuss definition. What is the definition of rate of reaction? Okay, rate of reaction. Now clear about visible?
Yes, sir. It is.
Yes, okay, good. So what is rate of reaction? Nothing but here, rate of reaction is nothing but the change in the concentration of reactants or products with time. So that is called rate of reaction. So definition of rate of reaction is change in the concentration of reactants or products with time. So that is called rate of reaction. So here definition is change in the concentration. Change in the concentration of reactants or products. Okay, so with time is called rate of reaction. So one more definition also there. You can write other one also. Here, decrease in the concentration of reactants or increase in the concentration of the products with time. So that is also called rate of reaction. So one definition is change in the concentration of reactants or product with time. So change in nothing but decrease or increase. So here one more definition is decrease in the concentration of reactants. Okay, with time. Or increase in the concentration of the products. Increase in the concentration of the products. Increase the concentration of the products with time is called rate of reaction. Okay, so rate of reaction can be written. So note, write on this one.
I wrote it, sir.
Okay, noted, huh?
Yeah, I wrote it.
Oh, correct. So rate nothing but here. Yes. So write the formula. So what is rate formula and what are the factors affecting the rate of reaction and types of reaction? So in EAMCET point of view or mains and advanced level, so it will come one question or two question will come. So you know the pattern of EAMCET.
So I am not used to write MCET papers. I don't know.
Okay.
Till I've only written like 4 exams.
So what
I'm writing right
actually number
previous.
of questions, chemistry questions, you know the number of chemistry questions in the MCET? Number of questions
No,
in chemistry. So you are MPC or BPC?
MPC.
Okay. So you are
So
appearing
like
for the.
exam, so I only know according to that. I actually want MCET question. So
Okay, right. Okay. So next, rate. So rate of reaction. So can write as a dx by dt or dc by dt. So here x is equal to change in the concentration. Change in the concentration. Clear. So here units. Rate of reaction units is equal to. So nothing but here concentration, nothing but moles. Moles per liter with time. Nothing but seconds. So here moles. So later will come liter inverse and second inverse. So these are the units of rate of reaction. Rate of reaction.
okay.
Okay, so how to write the rate of reaction is very important. Okay, so I know, I think you know the units of rate of reaction. So how to write the rate of reaction? So and based on this, there is a problem also there. Clear? Any doubt in this units?
No, sir. All
Okay, good.
I
So next,
that is in section. I got.
okay, correct. For example, how to write the rate of reaction of chemical compounds? So for example, here N2 plus 3 moles of H2 gas to form the 2 moles of ammonia gas. So here, how to write the rate of reaction? Okay, so here, rate of reaction is equal to here minus of d of N2 divided by dt with time. Okay, so here that is equal to minus 1 by 3 of d of H2 gas divided by dt. So that is equal to 1 by 2 of rate of reaction of ammonia divided by the dt, ammonia gas. So general example of paper process. So preparation of ammonia. So general equation. So how to convert the rate of reaction? Nothing but here. So reactants of N2. So convert as a minus of d of N2 divided by dt. So that is equal to minus 1 by 3 of d of H2 divided by dt. That is equal to 1 by t of ammonia gas reaction. Okay, why you are writing negative value here? Negative here also no need to write positive value. And one more thing, so the coefficients of the reactants here, coefficients of the reactants and products, so will come in the reciprocal. So why you are writing a negative means, so definition wise, the decrease in the concentration of reactants with time. So that's why we are writing the negative value here. Okay,
Sir,
now
I didn't
so
get
these
it.
are the reactants.
Repeat it.
These are the reactants, and this is called product. So definition by what is the rate of the reaction here? The definition of the rate of reaction is decrease in the concentration of the reactants with time. Decrease nothing but, so you have to mention the negative value. Okay, negative value.
Okay.
So they are the reactants. Why you are writing positive, negative, nothing but here the increase in
It is
the
increased.
concentration of products with time. So that's why you have to write the positive or no need to write positive or write like this also. But here the coefficients of the reactants are products, so will come in the reciprocal. Okay, now so you can write a general equation also. General equation of rate of reaction. General rate of reaction you can write no problem. General rate of reaction. So for example, here m moles of A and n moles of B. So we'll give the P moles of C and Q moles of D products. So these are the reactants. So general equation of rate of reaction is, so they are the products. So here M comma N comma P comma Q. So they are the coefficients. Means number of moles. Number of moles are coefficients values. So these will come in the reciprocal. So general equation of rate of reaction is 1 by M minus 1 by M of rate of reaction d of A by dt, that is equal to minus 1 by N of d of B divided by dt with the time. So from that definition, okay, no? That is equal to, so your products, so concentration of products will increase now, so that's why we can write positive 1 by P of dc by dt, that is equal to 1 by Q, that is equal to d of capital D divided by dt. So this is the general rate of reaction, identification of the rate of reaction. So for example, M moles of A plus N moles of B reactants. So reacted each other, reaction with each other to form the P moles of C product and Q moles of product D. So can write the general form. General form of rate of reaction is minus 1 by M into d of A by dt. So he is a reactant. A comma B comma C comma. So here I can write here A comma B are reactants and C comma D are products. Right? Sirisha, clear na?
Yeah, I got it.
So this is the general form of rate of reaction. Okay, based on this examination point, MCET or mains or advanced level. So from this equation, there is a problems. Okay,
Okay.
I will give one problem based on this equation. So write down one problem.
I'll take a note of this.
Sorry.
I'll take a note of this. I haven't written this. I'll write it.
Okay, write down the question. One question I will tell you. One question based on this. So previous, this is MCET point of view and mains are also given. So one question is there. So up here clear na? No doubts na?
No doubt.
Okay, good. So here one reaction is there and same
Yeah.
model based on this rate of reaction. So for a equation, so question is question number 1 for a equation. So there is equation here A plus 2B. So based on the rate of reaction, there is an example of question. So this is the question. For a equation, rate of reaction is equal to A plus 2B. So here A and B are reactants. C is the product. Okay, C is the product. So question, the rate of formation of So previous MCET level questions, rate of formation of C is equal to 0.05 moles per liter second inverse or mole second inverse. Mole second inverse. Okay, and calculate the rate of conjunction of A and B. Conjunction of A comma B, you have to find out. Okay, so question is for a equation. So A plus 2B gives C product here. A and B are reactants. C is the product here. So for the question, the rate of the formation of C. C is the product is moles per second given. Okay, C value given. So we have to find out the conjunction of A comma B. We have to find out A and B. So I think rate of reaction. So based on the equation, how the general equation given. So tell me the A value and B value. So first of all, you have to convert the equation into rate of reaction. Minus, what is the A value?
A value 1.
A is equal to? What is A and 1? A is equal to 1. B is equal to?
Minus 2.
B is equal to minus?
2.
Okay, good. So I will tell the equation right now. So here, so we have to convert the equation into rate of reaction. So here, d of minus a by t. You can write no problem. Minus of a by d at all, you can write no problem. Minus that is equal to reciprocal will come 1 by 2 d of b by dt. This is the equation. So plus dc by dt. So this is the rate of reaction of given equation. So already, so we have to find out the individual. Okay, one by one we have to find out. So given that value, given that dc by dt. So rate of formation of C. What is the value of C? 0.05 moles per second. So first of all, you can take dA by dt, minus of dA by dt. That is equal to dc by dt. So separate that one. And minus of 1 by 2 dB by dt. Both are equal, so dc by dt. So separately you can find out the A and B. So A is equal to already given 0.05. Right question, no need to calculation here. Rate of consumption, they are asking here, rate of consumption. So A is equal to 0.05, B is equal to here. You can write here also, here no problem. Okay, negative value you can write here or here also no problem. Okay, negative. Why you are writing negative means, so decreasing the concentration of reaction. That's why we have mentioned the concentration of reactants is negative value. You can write here also in brackets are like A. So you can write here also. One by.
So we don't have need to mention in the both. Right?
Yes, no need to mention the negative value. So can write directly also. So here B is equal to 1 by 2 now, minus of
Yes, sir.
dB by into minus of dB by dt is equal to 2 into 0.1. This C already given 0.05. So that is equal to visible.
No,
See,
sir, it is
so 2 into
right.
0.01.
0.05, right?
0.05. Nothing but 0.0 will come now. So here,
Yes, sir.
C is equal to 0.05. So it will come 0.01. Okay, na?
Okay.
2 into 5 into 10 power minus 2. Nothing but 10 into 10 power minus 2. That is equal to 0.1. Clear? So this is a consumption of A is equal to given that.
Can
same.
you repeat
Both
the
are equal.
last step again?
Reciprocal is there, na? So 1 by 2 into dB by dt, that is equal to dc. So dc by dt already given 0.05. So dB by dt is equal to cross multiplication.
2 into 0.05 equal to.
Yes.
Yeah, I got it.
You
Yeah,
get
okay.
a 0.0. Clear, na? Okay. So write on this one. So previous already this is the mains level our MCET question. So same MCET also will go. Yes. Now okay.
Okay, sir.
Okay, good. So this is the rate of reaction. So and general form of the rate of reaction. So based on this, there is a problem. So next, so what are the factors affecting the rate of reaction and types of reactions? So what are the factors affecting the rate of reaction? I think factors affecting the rate of reaction. So one by one we'll discuss. Yes. Here, factors affecting the rate of reaction. Okay, so what are the factors affecting the rate of reaction? So first one is nature of the reactants. Nature of the reactants and concentration of the reactants. So one by one we will discuss. Okay, see, third one is temperature. So temperature is also one factor affect the rate of reaction. Next, fourth one is the catalyst. So next concept, types of reaction also very important. So these are the types of reactions. So we'll discuss one by one. So EAMCET point of view in this topic, most important is rate of reaction and factors affecting rate of reaction, art of reaction, and molecularity of the reaction. So art of reaction, particularly zero order first start based on this. So examination point EAMCET or mains level will get the questions. Okay. So one by one we'll discuss. So main factors. So nature of the reactants, concentration of the reactants, okay, and temperature. Temperature. So temperature of the catalyst. So next types of reaction we'll discuss one by one. Okay, na? So how the nature of the reactor will affect on the rate of reaction. One by one discuss. Okay, now wrote down.
I wrote it.
Okay, right. Nature of the reactants. Nature of the reactants. Nature of the reactants. So in this main important is types of reactions will come. Very fast reactions. Very fast reactions are instantaneous reactants or reactions. So nature of the reactants. So these are the example of the nature of reactants. So how the affect the nature of reactants in the rate of reaction. So see, for example, most of the cases ionic reactions. So ionic reactions, covalent molecule reactions will affect the rate of reaction. So in this, strong acids and strong bases reactions. So reaction of strong acids and strong bases reaction. For example, so NaOH is a strong base. So HCl is a strong acid. So reaction will go. What are the product here? NaCl is a byproduct and H2 is a water molecule. Okay, here NaOH is strong base. This is called strong base. Sodium hydroxide. Strong base. This is called strong acid. HCl, hydrochloric acid. So sodium hydroxide. This is called strong base. This is called strong acid. Hydrochloric acid. So both are reaction. It takes place with formation of the NaCl, sodium chloride and water. So this is general equation or neutralization reaction also. This is also called here. This is salt, neutral product will form. This is also called neutralization reaction. Yes, Sirisha. Then one more example can take no problem. NaCl with silver nitrate. This is also one reaction. Nature of the here all is a nature of the reactants. So nature of the reactant will affect the rate of reaction. These are because most of the cases ionic reactions are very fast in the rate of reactions. These are ionic reactions, Na plus OH minus, Na plus Cl minus, here Ag plus NO3. So here the formation of product is sodium nitrate and AgCl. So here generally NaOH split into NaOH split into Na plus and OH minus, I think HCl, H plus and Cl minus. Okay, so these are the general equations. So NaCl will form, water will end. So second one here, NaCl, Na plus Cl minus. So these are all ionic reactions. These are the ionic reactions. These are all ionic reactions. So ionic reactions. So this is these reactions. Ionic reactions will participate in the rate of reaction. So these are very fast in the instant reactions. Nothing but here. These are all ionic reactions very fast. So these are completed in the fraction of seconds. So these are all completed in the fraction of seconds. So that's why these are called as a very fast reactions. Why? Because these form the ions Na plus Cl minus, Ag plus NO3 minus, Na plus OH minus, H plus Cl minus. So here Na plus and Cl minus will form the NaCl, OH minus and H plus form the water. Here Na plus and NO3 minus form the sodium nitrate. Here Cl minus react with Ag plus will form the AgCl is a phosphate. So these are so ionic reactions are very fast. So will form the precipitates also. Next, nature of the reactants, right? These are the based on the nature of the reactant. So the reactions are very fastly completed. Means fraction of seconds will complete. So these all affect the rate of reaction. Okay, clear now?
Okay.
Okay.
Yes.
So next one is concentration of the reactants. Types of reactions are three in this topic. So first one is very fast reactions. Very fast reactions. Yes, so this is also affect the rate of reactions. Very fast reactions are instantaneous reactions are both are called same. Instantaneous. Yes, these reactions affect the rate of reactions. Very fast reaction. One is second one is the moderate reaction. Moderate reactions. So third one is a very slow reaction. Very slow. Very slow reactions. So based on the reactivity of the reactants, so the reaction depends upon the rate of reaction. Okay, no? So here rate of reaction is depend upon the nature of the reaction also. Here, so very fast reaction nothing but here ionic reactions are very fast. Right? So it will come in a fraction of seconds. These reactions complete in a fraction of seconds. So just now we are written NaCl, AgNO3 means strong acid react to strong base. That is called neutralization. So these reactions coming in the very fast reactions. So next moderate reactions. Second one is moderate reaction. So this one moderate reactions. So here moderate reactions. So these reactions are completed. So these are completed in hours or minutes. Minutes also. Minutes or hours. Means it will come hours and days also, 1 day, 2 days or sometimes. Okay. So based on the nature of the reactions here. So for example, N2O5 is there. N2O5. So it will decompose and will form the 2 moles of nitrate and output. And decomposition of H2O2 also will form the water and of moles of oxygen. So this is a general equation of the moderate reaction. So these will complete in the hours. For example, 1 hour, 2 hours, sometimes 3 hours, sometimes 4 hours, depending upon the nature of the reactants. So these reactions affect the rate of reaction. Okay, good. Next, third one, very slow reactions. We'll see the. So write down this one. Note it up, or you can take a screenshot also. Very slow reactions. So tell me, you have any idea of very slow reactions? General morning onwards we observe daily very slow reactions. So daily life also daily we are observing the very slow reactions. Tell me the very slow reaction example. So simple here. Third one is our reaction is very slow reaction. Very slow reaction. So generally these reactions are completed. These reactions are completed the months or years also. Months or years. Means a longer time. Nothing but here, long time will take. Long time. Clear? So for example, simple daily awareness. So rusting of iron is a very slow reaction. Rusting of iron. Did you observe that? Very slow reaction, rusting of iron. So generally, iron react with moisture, atmosphere, oxygen. So generally gets windows. Nothing but here iron react with the atmosphere oxygen or moisture. So oxygen and it contain the water molecule also moisture. So you will form the X moles of water can take. So here 4 moles, 3 moles, we form the 2 moles of Fe2O3 into X moles of H2. So this is the ferric oxide or ferrous oxide will form. Byproducts, rusting. This is called rust formula. Fe2.